Okay, we're going to write polynomial functions of least degree with real coefficients in standard form when we are given zeros. Does anybody know what that means? No thoughts? No thoughts on what that means? We want to write polynomial functions of a least degree with real coefficients in standard form when given zeros. Alright, what we're doing today is the reverse of what we did yesterday. Yesterday we were given the polynomial functions and we were finding the zeros. Today they're given the zeros and we are writing the function. So that's what that is saying. We are writing the polynomial function when they give us zeros. Okay, we're going to do 2 examples and you're going to have 5 problems for homework. Alright, so I have 4 zeros, -3, 1, 2 square root of 3, and -2 square root of 3. What types of numbers are 2 square root of 3 and -2 square root of 3? So what type of numbers are 2 square root of 3 and -2 square root of 3? They're irrational numbers, that is correct. When you're doing, say it again. They are zeros, they're just not rational zeros. Okay? What we were doing yesterday, we were using the rational root theorem to find rational zeros. 1 and -3 are rational. The other 2 are irrational. Okay? So, an example of an irrational number, if I'm taking the square root of something that doesn't come out clean, it's an irrational number. For instance, I can't take the square root of 3 and make it come out as a clean number. The square root of 4, however, I can come out clean. Okay? But any square root of a number that doesn't come out clean is going to end up being an irrational number. Okay? What do you notice about the 2 radical 3 and the -2 radical 3? Okay, they're opposite signs. Why do you think they're opposite signs? There you go. Very good, Christian. Christian said if we were solving this polynomial we're getting ready to write, I would at some point had to take the square root, and whenever we take the square root, what else do we have to do? We have to do plus or minus. So anytime you see a square root, there should always be another one with it. You should always have opposite roots. Okay? So on the assignment today, sometimes they won't give you all of them. Sometimes they'll just give me something like, they'll say those are your zeros. Okay? And you've got to know that if I see one radical, what else has to be there? Negative. The matching one has to be there. Okay? So they're going to do that to you. They want you to be able to understand that if you have one radical, there's got to be another one that goes with it. So if I've got my zeros and I want to get back to the polynomial function they came from, what do you think we need to do? What? So just multiply them together like they said. Okay. So Natasha says multiply. Christian?
Well, with hard zeros, we know that the equation can have the largest exponent could possibly be 4.
Alright, so my largest exponent is going to be 4. We know that. Kathleen?
Wouldn't you just set them equal to x?
Set each of them equal to x. So if I have x equals -3, x equals 1, x equals 2 radical 3, and x equals -2 radical 3. Okay, and then what are you going to do?
Put them all on one side and then multiply.
What'd you say again?
Like, put the coefficients on the side of the x, set it equal to 0 now.
So
That way you have
set
your
each one of these equal to
factors.
0.
Mm-hmm.
Okay, so if I set each one of these equal to 0,
And then multiply multiply them.
Okay, and then take each one of these parts and multiply them out? Yes, that's what we want to do.
Whoa.
Okay? Except,
Where did you come from?
Well, you said it was the opposite of what we did yesterday, so we said
Okay,
it
yeah.
equal to 0.
what do we, on yesterday's assignment, what do we usually finish up doing at the end of the problem? We usually factored it, and after we factor it, what do we usually do? Set it equal to 0, and then after we set it equal to 0, what do we usually do? Solve for the number. So now we're just doing the total reverse of that, which is what Kathleen was thinking. She was saying, so we set them all equal, because that's where it's at. We moved it back over, and then the reverse of factoring is multiplying. Okay, so that's what's going on there. Now, I'm going to expect us to be able to go straight to this point right here, though. Okay, I'm going to want us to go from here directly to that point, but I'm glad Kathleen walked us through that step so you guys can understand how we get to that point. Okay, so we're going to go straight from the zeros to this point right here. And then once I get to this point, all I've got to do is multiply everything out, and I've got my polynomial function. Say it again.
That's all.
That's it.
That's the answer.
I'm not, no, I've got to multiply that.
Oh.
Okay, so I'm going to multiply these two together and multiply those two together. What's required to multiply that?
Could you do the box?
Box method. Box method. Foil?
It's like E plus 3.
It's easier than foil?
Yes. A lot easier.
Well, tell me what it is then. So
You make a
I'll
box and you put x plus 3 on the top of it and x minus 1 on the side.
Here, I'll just do it.
yeah, come up here and do it. I'm interested to see.
Camera.
I'm probably not going to like it.
Come on now.
He already has a job.
What is this? This looks like biology.
This is biology.
Yeah.
Hey, biology.
What grade? What do you do these
It's plus 2x.
grade?
Plus 2x.
Yeah.
I've had
There you go.
geometry
Does it work?
because of the test.
And whatever floats your boat. That doesn't float my boat. So we had x squared plus 2x minus 3. Now, what do I have over here on the right side? What are those called? Anybody know what those things are called? X minus 2 radical 3 and x plus 2 radical 3. They have a special name.
Oh.
Bless you.
Bless you.
They are binomials, but that's not special.
You said the word like 2 days ago.
Starts with a C.
Camera.
Catastrophic.
I think of a lot of C words, so keep naming C words. We'll get it one day.
Conjugates. I knew that.
Okay, and those are called conjugates, and that's a word we're going to use over and over again this year, and use over and over again next year. Okay, that's a word we need to know. Okay, so what are conjugates? Looking at these, what would be the definition of a conjugate? Okay, clean that up a little bit. Questions?
Same equation, opposite signs.
I have same binomials with opposite signs in the middle. That's what conjugates are. So these binomials are the same except for the sign in the middle. If you have binomials that are the same except for the sign in the middle, they are conjugates. Okay? Now, what is the good thing about knowing they're conjugates?
The middle
The middle ones cancel out. So all I have to worry about when I'm multiplying conjugates is the front times the front, which is x squared, and the back times the back. Does anybody know what the back times the back would end up giving me?
4 squares.
4 squares, please.
Negative 12.
12 is what we end up with. Okay, Natasha, explain to everybody how you got 12 out of that.
Negative 2 times 2, which would be negative 4, and then the square root of 3 times the square root of 3 would cancel out the square root, so it just 3 times negative.
Very good. Everybody hear that? She did 2 times 2, which gives me the 4, and radical 3 times radical 3 is just 3, so 3 times 4 gives me 12. So that's where we get it from. Okay, then once I get here, I just need to multiply one more time. I'm going to take x squared times both of these, 2x times both of these, and then negative 3 times both of these. That's how you multiply the rest of this out. So I get x to the 4th minus 12x squared plus 2x cubed minus 24x minus 3x squared, and then plus 36.
Whoa.
There's no guessing.
That is.
So these first two came from the x squared, these second two came from the 2x, and the last two came from the negative 3. Now all I need to do is clean it up. So x to the 4th is there. I've got x cubed, 2x cubed is there. I've got 2 of the x squared, so that's minus 15 x squared. So those are gone. I've got a minus 24x, and then I have a plus 36. And there is my function.
AJ.
You wait,
AJ.
Hey, Jeff, your clock phone. So, what do I know about that polynomial function I just wrote?
it has actors.
It has zeros of negative 3, 1, 2 radical 3, negative 2 radical 3. What's something I can do very quickly to see if I did that right? Alright, do synthetic division with one of my zeros, and what should happen? Zero remainder. So let's do that real quick. And which one of those zeros would be easiest to use? 1. So let's do that with 1. So I've got 1, 2, negative 15, negative 24, 36. And since I got a 0, that means more than likely I did my polynomial correctly. Okay? Alright, let's do one more of those. This one is going to involve complex numbers. What are complex numbers?
Big number.
Is this right?
A complex number is a real number plus or minus an imaginary number. Okay, so the 6 minus I and the 6 plus I are complex numbers because I have a real number and it's plus or minus an imaginary number. Okay? Complex numbers are just like those radicals. How are they like the radicals? They always come in pairs. Complex numbers always come in pairs. So when you do your assignment, they might only give you one of the complex numbers, and they're expecting you to understand that if you have one complex number, you know there's automatically another one. Okay, so they're going to do that to you on your assignment. So we want to write the polynomial. So for negative 1, what's my factor going to be? X plus 1. For 4, x minus 4. What about for the 6 minus I? X minus 6 plus I. The negative needs to be distributed to both of them. And the other one is going to be x minus 6 minus I.
Okay.
Okay, so we multiply this out right here. So that is x squared minus 4x plus x minus 4. So we're looking at x squared minus 3x minus 4. Now on the other one, I've just got to take each term times each term over here. So x times x is x squared, x times negative 6, x times negative I. So all of that came from the x. Then I need the negative 6. So negative 6x plus 36 and 6I. So all that came from the negative 6. And then I need the I. So I have xi, I have negative 6I, and I have negative I squared. So all that came from the I. Now, when you're multiplying out factors that involve complex numbers, here's something that always happens so you can keep everything straight. Anything with an I should go away, or the I should change. So anything that has an I should cancel out. So since this negative xi right here has an I in it, it should cancel with something. What is it going to cancel with? The positive xi. So that should cancel, and that should cancel. I've got a 6i, so that needs to go away. So notice it cancels with the negative 6i. And then what is I squared equal to? Negative 1, so that turns into a positive 1. So we're looking at x squared minus 12x plus 37. Okay, so you need to keep that in mind whenever you're multiplying out factors that have complex numbers. The I should always cancel, or the I squared goes to negative 1.
How did you cancel out that I squared?
It goes to negative 1. I squared is the same thing as negative 1. So I replaced it with negative 1, and it was already negative, so that made it a positive 1. Now it's just a matter of multiplying all this out. So I need x squared times everything, so that's x to the 4th minus 12x cubed plus 37x squared. So there's the first set. Then I need the negative 3x. So minus 3x cubed plus 36x squared and minus, if I remember right, I think that was 111x. And then I need the minus 4, so minus 4x squared plus 48x and minus, that is 41, negative 148. And then just put my like terms together. So I have an x to the 4th. So I've got a cube and a cube, which is negative 15x cubed. I've got a square, and a square. So negative 4 and 36 is 32. 32 and 37 is 69. Then I have those, so that's 52, negative 63. And then I have the minus 148. So there is my function. And it has zeros of negative 1, 4, 6 minus I, and 6 plus I. And real quickly, since it's very easy to do, let's go ahead and divide to verify we did it correctly. So which 0 do I want to use? Negative 1. So 1, negative 15, 69, negative 63, and negative 148. So 1, negative 16, 16, 85, negative 85, negative 148, and positive 148. So that means more than likely our function was written correctly. So that is writing a polynomial of least degree with real coefficients in standard form when you are given zeros. So you write it in factor form and multiply it out. That's pretty much all there is to it. And if they give me one radical, I always need to know what? It should come in pairs. And if they give me one complex number, there should be another complex number to go with it. Question? All right.